In this session, we'll address integrated forecasting and replenishment at a high level. We'll talk about statistical forecast based on historical usage, customer collaborative forecast, sporadic items, vendor replenishment, branch replenishment, hub and spoke, if it's appropriate, inventory balancing, and then analysis. So the basis of forecasting and replenishment actually starts with historical usage. Now this is usage that we think will reoccur, or that we would like to think that will reoccur. So it actually takes a little bit of work to get to that point. So for example, we like to start our system with 2 years worth of history, and we like to have smooth usage. So basically what we're trying to say here is that either you have adjusted it in the past, or we'll let the system smooth the historical usage. And we have algorithms that make that happen. Going forward, we will give you alerts when historical usage is totally out of the ordinary. And quite often when that happens, we'll recognize that's a one-time sale or something of that sort. So what we want to do is to get historical usage as accurate as possible. The more accurate and consistent that historical usage is, then the more accurate your forecast will be. And by the way, every time that I mention adjustments, and I'll mention that a lot in this presentation, I want you to understand that we're not actually changing numbers in the system. When we adjust, let's say, a forecast from 50 to 75, the system actually creates that transaction of positive 25. If we adjust it down, it'll create a negative transaction. We will date and timestamp that transaction and take the user ID that caused that to happen as well. So basically what we're doing with adjustments is actually making adjustments to the end result, but you still see what the original numbers were. For example, the original numbers in historical usage, and if someone adjusted it down or up, you'll see that. Okay, the next thing that we do is once we have reasonably good historical usage, and by the way, one of the things, let me go back for a second and talk a little bit more about historical usage. One of the things that happens, especially in, say, an electronics industry, but almost in all industries, you will stop carrying an item and then replace that item with another one, and you really don't have any history on the new item. What we do is we redirect the history from the old item to the new item, and then we start the new item with the history of the old dynamically, and we move forward with a reasonably accurate forecast on this replacement item. Okay. The other thing that we do is cloning usage, and this allows us to say, I'm starting to carry a new item, and it's going to sell similar, or at least it's similar patterns to another item in the past. So I'm going to say I want to take this other item and take 70%, let's say, of that forecast of that item. So 70% of the time when I sell one of those, I'll sell one of these. And it'll actually move this, not move, but actually copy or clone the history from the old item to the new. So it's another way of starting new items if they are related to anything, any items that you currently sell. So then let's go forward with the forecasting engine. You'll see this forecasting engine takes historical usage and creates a total forecast. You could refer to that as a statistical forecast or a history-based forecast. The forecasting engine is a best fit formula approach. I mentioned that in previous videos, and basically what we're doing there is we're reforecasting the past multiple times for every item in every warehouse, choosing the formula that best performed in that situation and then use it for that item in that warehouse to predict the future. So it's quite often that when we go from one period to the next, we might change a formula because your patterns have changed. Your historical usage patterns might have changed on that item. maybe another formula best performed in this analysis that we do when we create the forecast. So again, a dynamic scenario where we're actually assigning the best formula to an item. Now, one of the other things you can do is you can say, I want this group of formulas to be used on this item or this group of items. So we can actually interrupt the system and make some more directed input there. But basically, most of our customers, 98–99% of their items or better, are actually used with the dynamic forecast assignment, our best fit formula approach. So again, now let's say that we create a forecast that's reasonably accurate. The first thing that happens once we create a forecast is that someone says, gee, I know something the system doesn't know, and I need to make an adjustment. We allow you to adjust it at the stock keeping unit level, which is the warehouse and item. We allow you to adjust it across a product line. So let's say you know that a product line is going up or down based on some conditions, and you can actually run a process in the system that'll increase by some percentage and make those forecast adjustments as far out as you want to make them. Okay, so that can happen. And again, remember, the adjustment didn't change the original forecast, it just created another transaction added to it. And you'll see that when we do the video on the demo of the system. You'll see how that works. The next thing is a forecast summary. So quite often, and I would imagine anyone listening to the video would basically say that, gee, I'd like to see what my forecast is at the company level, the warehouse level, maybe a product line level, maybe a ranking level, or that type of thing. So we have a forecast summary, and you define how you want your forecast rolled up. But when we do roll that up, we show you units, which really doesn't mean a lot in most industries at the summary level. But we do that anyway because in some industries, board feet or pounds or something of that sort does mean something at the summary level. But then we also show you cost and price at those summary levels. If you want to use this summary to make a forecast adjustment, you can change either the quantity or the cost or price at any of the summary levels and say, let me see what happens if I adjust that, if I take my cost of goods sold up on that given item or product line, or that product line. And basically, then what happens, it looks at the percentage of the increase that you've done and then it adjusts the items in that category up or down, whichever whichever change you've made, and then it will roll up. It'll extend the lower level and roll it back up again. So it's kind of a what-if approach if you change things. Okay, and then you can push a button and say execute this change that I've just made. So it can be used for reporting and looking at your forecast at a cost and price level, but it also can be used to actually adjust the forecast as well. The next thing is a collaborative forecast, and I think we'll probably have a separate video on the details of collaborative forecasting because it is kind of its own animal itself. But basically what we're trying to do here is we're trying to collaborate with a customer, get customers' input and or sales reps' input about a customer. And we don't do this with all of our customers. We don't do it with all the items they buy from us. It's the fast-moving items for the large customers and the customers that will collaborate with us, and also the customers that, when doing this in the past, have been reasonably accurate. If they're not accurate by what they're telling you, then of course it doesn't make sense to do it. If you sell to big box retailers, if you import product and sell to the big box retailers, then it's very common to have them provide a forecast. What happens a lot of times is they'll provide a forecast that's not really accurate, but you'll bring that into the system and then you'll get into trouble with it. Well, you need to collaborate with that customer. Say, okay, let's take this forecast you gave us for the last 3 months and let's look at it, and you're 20% low or 40% high or whatever it happens to be. And so you can try and collaborate with them and get a better forecast. If you can't do that, you can adjust it yourself, or you could just decide that you don't want to collaboratively forecast with that customer. Now, we do analyze, of course, the collaborative forecast that we arrive at, and over time look at what actually that customer bought. So we have all sorts of data that supports or does not support that collaborative forecast. Notice there's an arrow going from the collaborative forecast back to historical usage. And basically what happens is if I'm going to collaborate on a customer item combination, I'd like to flag my historical usage for that customer not to be used in the statistical or total forecast that we talked about, because now I would like to add my collaborative forecast to my statistical forecast and get a total forecast that's a lot more accurate. So that's why we have a historical, that arrow going back to historical usage there. The next thing is sales promotions. Sales promotions, if you do them, is really a good thing, because what it's actually doing is hopefully increasing sales. But it has a byproduct that's not so good sometimes. If you run a sales promotion and, let's say, increase a given item by a huge percentage, if you don't do something with your historical usage, now you're going to overbuy that when you're not running that promotion. So the promotion has two main jobs in the system. One is I put a promotion in and what I think the result will be. It will increase the forecast in the future, so I can see that I'm going to consume inventory that was surplus or excess, potentially. So I can see how much of that I'm going to consume. Or I might have to buy more product for the anticipated promotion. And so what happens there then is I increase the forecast in the future. I will have the products that I need. And then after the fact, after the promotion period, I need to go back and analyze, and the system will help you analyze what the results of that promotion is and what you achieved, so that adjustment, and notice again the arrow going back to historical usage, we're actually adjusting that historical usage down. We're actually removing the result of that sales promotion using an adjustment again concept, which basically says that promotion never happened historically, so now I have a better forecast going forward. Okay? So what we have now is hopefully the most accurate forecast that we can arrive at. And that forecast goes two places. Number one, if you do production, or you repackage items or send items out and change them internally, do some light manufacturing, something of that sort, then it would be considered production. So, and also kitting. So, for example, if I buy an item and sell it, and then I also buy an item and make it part of a kit. Maybe there's no assembly required, but at picking time, I just sell these in a group. Okay. So the end result here that we want to have is basically the forecast for the production item and or the kit should drive component demand down into the replenishment side. So we want to see going forward a time-phased estimation of what we need in terms of components based on the forecast of the production item and or kitting item. Now, if you buy and resell an item, in the center of the screen there, that forecast will go into replenishment. So if you're a pure distributor and you never do kitting and you never do production, then you would use the forecast going into the replenishment in the center of the screen to say I buy and resell this item. In the real world, what I find is that most distributors will actually buy and resell an item and also use it as part of a kit and maybe even part of production. So you have demand coming from all sorts of places. We need to actually recognize that demand as coming from components or as coming from sales of the item. And when we demonstrate the software in future videos, you'll see how we analyze that and how that happens. So in the replenishment block, we're all about trying to say, what do we need to buy? What inventory do we need to bring in from the vendor at the right level, and where do we need to bring it? So the first thing we want to look at is time-phased expected inventory. Now, every ERP system, almost every ERP system that I've seen, has an expected date for every transaction. A sales order must ship on a certain date. A purchase order is expected to be received on a certain date. I'm transferring inventory from warehouse A to warehouse B on this date. I'm producing product in production. There's all sorts of things that could be happening here, but it's all time-phased. Future sales orders, future purchase orders, those kinds of things. So I want to look at that in a time-phase mode. And then I want to analyze my lead time. I want to know, as I mentioned earlier, I want to know what the lead time is on a given item in a warehouse from a given vendor. And I analyze that lead time. You can also set that lead time to something that you can live with if it's all over the board as well. But if we can analyze it, we'll run based on that. So we have our lead time calculation, and a given vendor might have a 10-day lead time on one item and a 60-day lead time on another. The next thing is vendor targets. So when I'm creating this suggested order, the system says you need to buy this quantity of these items, and it makes a recommendation. We then summarize that at net weight, gross weight, dollars, and volume, and compare it to the targets that you've set in the system for that vendor. Maybe you need to reach a minimum dollar amount. Maybe you need to buy a truckload or a container load or something of that sort. So net weight, gross weight might come into play, or volume there. So basically, we show you the targets. We don't automatically adjust the suggested order up to meet these targets, but we give you the numbers and we give you a way to actually say, I want to increase this suggested order to a certain point for these targets. And the way I might do that is say, I want another 5 days, 6 days, 7 days worth of inventory to reach that target. The next thing that happens, and this is really common in companies that have multiple warehouses, which most companies do. What we have is we're buying an item in one warehouse and we have a surplus in another. We might be buying 100 units and have 200 units scattered across 2 or 3 warehouses, or maybe 200 units in one warehouse. So we might say, the buyer might make a determination, gee, I see that 200 units of surplus inventory there. I want to bring that in instead of buying, or I want to bring in part of it because I have an urgent need, and then I want to buy the net of what I need less that transfer. So basically the end result then on a suggested order could be a transfer order or transfer orders, depending on where you're pulling inventory from, and then a purchase order. So basically, this is the concept at a high level, which basically says, let's get the most accurate forecast possible, and then let's apply some dynamic controls to it to buy the right product. And then in future sessions, we're going to talk about surplus and excess inventories and things of that sort. So let's look at how we make a determination of vendor replenishment. And if you're doing this today on a spreadsheet, which, by the way, a spreadsheet is the most commonly used forecasting tool in the industry, I think. But if you're doing this today, you're doing something similar to this, so I think it'll make sense. But what we're doing is we're slicing it a bit thinner and doing it a bit more accurately, and I think you'll understand what I'm talking about here. So basically, lead time horizon calculation is made up of 3 numbers, basically. It's made up of my lead time days. That's how long it takes me to from the time of placing a purchase order to receiving the purchase order. The review cycle days, that's how often I place a purchase order. I need to add that so I make sure I have enough inventory. So if it's 30 days, I add 30 days. If it's 7 days or 14 days, I add those. And then safety stock. And safety stock can be calculated dynamically by the system, or you can actually set that safety stock. So basically in my case here, I have a 60-day lead time, a 7-day review cycle, and a 14-day safety stock. That's 81 days. So I need to have enough inventory on hand or on order that will be delivered before that date that will keep me with enough inventory. Okay. Now, what I would really like from a planning standpoint, and this makes some people nervous, what I'd like to have at the end of that 81 days is to have a time-phased expected inventory compared to the forecast, and I'd like that time-phased expected inventory to be 0. Because it will never get to 0, because if you're buying it every 7 days, you're going to place another order in another 7 days, and so you're going to be buying smaller increments 7 days at a time as you go forward, right? But basically, if I do this, I'm buying for the 81 days, and if it's 0, I'm happy. If it's positive, I have too much. If it's very positive, and quite a large number at the end of that, in terms of time-phased inventory, I might have something I'd classify as surplus, or excess, I'm sorry. And if it's negative, I'll buy at least the amount negative. Now, there's all sorts of other things that we use, economic order quantity calculations and those kind of things that might increase that quantity we're buying. But at a minimum, whatever my time phase expected inventory is there and whatever the negative quantity might be is what I need to buy at a minimum to have the right amount of inventory going forward. And so that's basically a reasonably simple concept. It's a little bit tough to execute in a computer system because you have to crunch a lot of numbers to make all this happen, but I think it's the most accurate way of actually buying product and getting it in a little bit more of a just-in-time inventory. Now, we add some things to the just-in-time concept, as I said, of EOQ and vendor targets and those kind of things, but this is how we analyze whether you have the right amount of inventory, you have surplus inventory, you have excess inventory. And so that's kind of a concept of distribution requirements planning. I add a little bit more to that, and we start talking about roll-up, and we start talking about taking historical usage and rolling it up to the source and all those kind of things. So let me kind of explain the concept here. Basically, hub and spoke is a concept of when I need inventory, where do I need to get it from, or where will I get it from? So if I'm in a warehouse and I get my inventory from another warehouse, I'm a spoke to that warehouse. I might have another warehouse that the second one gets his inventory from and things of that sort, and I'll show you a graphic in a minute that will kind of explain that. But what we want to do is to take the history from the lowest level all the way to the top on that given item, and we want to create a forecast at every level. Once we do that, we know what we need to buy at the top for the guy at the top and everyone under him. We know what we need at the second level for the warehouses at the second level might supply, and then a lot of times the third level is really consigned warehouses, consigned inventory with customers and things of that sort. So basically we use this whole concept not only for buying from the vendor, but replenishing branches and replenishing customers in terms of the consigned inventory concept. It's really important to note here that we are actually rolling up historical usage and creating a forecast at the top level. The reason for that is if I have a number of warehouses under me, and their inventory or their sales pattern might be pretty sporadic, but as I roll that to the top and I combine those together, a lot of times I'll get a pretty good accurate forecast. So I might be able to I might be able to forecast accurately at the top and then bring that product in and move it down to the warehouses in smaller quantities. So let's look at the concept of setting up a replenishment path, hub and spoke. And here's an item, and you can imagine that this would be a single item. I'm in warehouse 1 and 2, I buy from vendor 1. In warehouse 3, I buy from vendor 2. And in warehouse 1 supplies warehouse 4, 5, and 6. And then warehouse 9 gets his inventory from 5, and so on. Okay, so the concept is at the top level where I buy from the vendor, I need to have on order or on hand enough inventory from me and everyone I supply through the vendor lead time, review cycle, and safety stock, which is that lead time horizon we talked about, right? So I at least have on order or in stock everything I need for that, okay? Now, what you might jump to a conclusion here and say, well, gee, when I get that in, I'll immediately move it all down to the warehouses and I'll carry, let's say, my 90-day inventory in all those warehouses. I'd like to suggest not to do that, because if you do that, if you go ahead and push that inventory down to the warehouses, you have an excellent chance of being overstocked in one warehouse and understocked in another, and quite severely because you're carrying 90 days worth of inventory there. No need to really do that, probably. Okay? It depends on how you push inventory and how expensive it is to move and all those kinds of things. But if I carry that 90 days worth of inventory in warehouse 1, warehouse 4, 5, and 6, if I have a truck that might be, those might be regional warehouses, and I might send a truck once a week or something of that sort, maybe I need 14 to 21 days, maybe 30 days worth of inventory at each of these warehouses, but I certainly don't need the whole 90 days. And if one of the warehouses sell more, they will get more from me. If they sell less, they'll get less from me. And so what you're actually doing is keeping less inventory in the spoke levels and more in the top level. And what happens is you really effectively reduce your safety stock. Because one warehouse will sell more, one will sell less. The net of that is kind of a zero. So basically that great safety stock that you're carrying may not be needed. And so you might over time reduce your safety stock there and still keep your customer service level where you want it to be. The next thing that we do is inventory balancing. Now, inventory balancing, either in a hub and spoke, or maybe if you don't do hub and spoke, quite often, and maybe quite often might be once a month or once a quarter, you might analyze inventory and say, gee, I have a need here and I have surplus here or excess here. And again, we don't suggest that you move inventory around just to move it to where you think you need it. We suggest to move it when you have a need, or when you foresee a need based on forecast. And so the system will actually suggest replenishing certain warehouses from others that maybe are not even in their replenishment path. And one of the things that we do here is we also set up a priority. So if I have warehouses all over the U.S. as an example, I might not want to ship from New York to L.A., but I might want to ship from Phoenix to L.A. and L.A. to Phoenix, and maybe New York to Chicago, those kind of things. So basically, I can set up priorities of how this all works. And it's a recommendation in the system. It's not something that just happens when you run it. You run it, it makes a suggestion, and then you analyze that yourself and make a determination of what you're going to do and what inventory you're going to move around. So that concludes this section of the forecasting replenishment overview. Please join us for other videos in terms of demonstrating the software and those kinds of things. Thank you very much.